Okay, let's work with some inequalities. Solving inequalities is the name of this lesson. It says consider the inequality x squared plus 4x is greater than or equal to 5. Sift through the possible values to assign to x that makes the inequality a true statement. Find at least 2 positive values that will work and at least 2 negative values that will work. Should your 4 values as a solution blah blah be equal by that? Okay, sure. Explain why or why not. Should your values be the solution explained by that? Sure. Okay. These are pretty simple questions here. All right, so to solve for this, we're going to simply set it up like an equation. I'll say x squared plus 4x greater than or equal to 5. Well, what can we do here to answer this equation? Let's do this. I'm trying to do it without doing algebra 2 stuff with you. Okay, let's just do this. What if I said, let's just find some. Let's just say 1. Does 1 work? So 1 squared plus 4 times 1, is that greater than or equal to 5? Well, this will be 1 plus 4. That is greater than or equal to 5. That works out. All right, so 1 works. What about 2? If I plug 2 in, 2 squared plus 4 times 2, that greater than or equal to 5. Well, that's 4 plus 8. Well, of course, that's going to be greater than or equal to 5, so that works out. And notice that this is 5. So this would be the lowest number we could go with for it to be greater than or equal to 5. 1 is. Right? So we would say that x is greater than or equal to 1. All right, let's find another one. Okay. This is our equation. Oh, sorry, it's supposed to be an eraser. There we go. Now, let's talk about wanting to find positive and a negative. Well, there's our positive. Let's think about some negative terms. Okay, what if I tried negative 4? Plug in negative 4 here. Well, negative 4 times negative 4 is 16 plus, what's 4 times negative 4? That's 16. Negative, is that greater than or equal to 5? Well, no. 16 minus 16 is 0. That is not equal to 5. So negative 4 does not work. Now think about it. Are we going to have to go towards 0, or are we going to go farther to the left on the number line? Well, let's just try 0. If we plug in 0 here and 0 here, that's going to give us 0. 0 is not greater than or equal to 5, so that won't work either. So let's come back and let's say negative 5. If I plug in negative 5 squared plus 4 times negative 5, does that give me something greater than or equal to 5? Well, this is 25 plus 20, a negative 20. So if I subtract that, that's going to give me 5 is greater than or equal to 5. So that works out. So negative 5 is another one. So what we would have to say, it has to be, x has to be less than or equal to a negative 5. And what I mean by that is, if I take and say negative 6, so that's less than negative 5, right? So if I take negative 6 and plug that in, let's plug it in right here. does that equal something greater than or equal to -5? Well, -6 squared is 36 plus a -24. When I subtract that, I get 12. Is that greater than or equal to 5? Sure. So yeah, it's got to be less than. We tried -4, it wouldn't. -5 would, and -6 will. So it's got to be, x has got to be less than or equal to -5. All right. Should your values also be the solution of? Yes, because this is all this is rewritten. X squared plus 4x. If you were to break that apart, okay, divide by, so you're going to take this and you can divide by x. Well, x times what gives me x squared? X. X times what gives me 4x? 4. If I do distributive property, that's what I'm going to end up with. X squared plus 4x. So that should work. This is simply commutative property. They just wrote it backwards. You had 4x, x squared plus 4x. Now you write 4x plus x squared. That's the same thing. Doesn't matter. That's commutative property. So yeah. All right. Should your 4 values, blah, blah, blah. Okay, so our original equation was x squared plus 4x greater than or equal to 5. Well, what they did was they subtracted 6 from both sides. So x squared plus 4x minus 6 greater than or equal to -1. Yeah, that's going to work because you did the same thing to both sides. That is the same thing. All they did was subtract 6 from both sides. So yeah, the same thing. All right, what about 12x plus 3x squared greater than or equal to 15? Yeah, because all they did here was, eraser's not wanting to do it. All they did was multiply by 3 on both sides. They said 3 times all of that and 5 times 3. That gives me 3x squared plus 12x greater than or equal to 15. Sure, that's the exact same thing. They just multiply by 3 on both sides, so it's going to be the exact thing. What is the solution set to the inequality 5q plus 10 is greater than 20? Express the solution in set, or in words, in set notation, and graphically on a number line. All right, well, let's just do that. Let's just solve. If we were to do that, 5q plus 10 greater than 20. Let's subtract by 10. 5q, that cancels, greater than 10. Now divide by 5. Divide by 5. Q greater than 2. There's your answer. So in words, we would say Q can be any value that is more than, make this a Q so it don't look like a 9. Q, as long as it's greater than 2. So any Q greater than 2. All right. How would we do that in set notation? We would say Q greater than 2. Okay, if you want to put your little numbers there, that's fine too. Now, we would also say by doing a number line, and I just put the 2 in the middle. It's got to be greater than 2. It cannot be 2. 2 will not work because it has to be greater than 20, not 20, greater than 20. So you have an open circle. number 4, or page 4, sorry. All right, so we just solve these. Let's just subtract 4. Those cancel. X is less than or equal to 3. So that's notation. We do that on a number line. This is or equal to, so we're going to fill that circle in because it can be 3 or anything less than. All right, so I'm going to subtract 8. Ooh, notice this can't be 9. Okay. So m over 3 is equal to 1. I would multiply by 3. Multiply by 3. M is not equal to 3. It cannot be 3 because we don't want it to equal 9. So how do we do that so that it is not 3? So what is that on a number line? That's an open circle, and anything that is not 3. M cannot be 3. It can be anything else, but it cannot be 3. All right, let's do another one here. I'm going to subtract 7y because I like working with positive integers, or not positive integers, positive variables. This gives me y. So I'm going to have to subtract 4 from both sides. So if I subtract 4 and subtract 4, oh, that's not an equal. Got to be careful. Can't always throw an equal symbol down there. That is less than. So that would be what? -6. All right. There's my notation. Let's do -6. So it's got to be not including. So it's just an open circle. The only time you do a closed circle is if it's or equal to. This is not or equal to. All right, 5, page 5. Okay, let's go ahead and do, all right, there's 2 different ways you could do this. I'm going to go ahead, since I know this is 6 times this, I'm just going to divide by 6. That's going to leave me with x minus 5 greater than or equal to 5. If I add 5 to both sides, x has got to be greater than or equal to 0, not 0, 10. That's it, 10. This cancels. Leaves me with x is greater than or equal to 10. So if I was to graph that, this is 10. Excuse me. This is greater than or equal to. Since we have our or equal to here, we have to fill in that circle. Now let's go everything to the right of the number line. Okay. Now, since this is 4 times x minus 3 and 2 times x minus 4, I'm going to go ahead and divide by 2. Divide by 2, and that's going to be 2 times x minus 3 greater than x minus 2. Now, what I'm going to have to do is I'm going to go ahead and say, distribute this. Now I'm going to subtract x. That leaves me with x minus 6 greater than -2. Add 6, x is greater than 4. Okay, now if I do that on a graph, I'm going to put 4. And since it's not equal to, it's an open sign, it's an open circle, and anything to the right. And normally, look, I'm just going whichever way this is pointing. Okay, pointing that way, so I'm going that way. X has got to be greater. Now, remember, we've been talking about all the things that can be done to both sides of the equation. It doesn't matter, right? So what does it mean if we square, if we're squaring something? Is it the same thing? Remember, we've talked about this. No, it is not, because it can be a plus or a minus. Okay, b is not less than or equal to 6 whenever it's b squared. Okay, not the same. And you can prove that by saying, look, for this one, it's got to be less than or equal to. So it could be 6. That's a true statement. It could be 5. That's a true statement. It could be -3. That's a true statement. But if we say b squared, and so we square root that, we square root both sides, that means b is greater than or equal to plus or minus 6. Okay, and so let's see. What if I did less than or equal to? What if I did, let's do 5 again. We said this was correct. So if I said 5 squared greater than or equal to 36, or less than or equal to 36, is that true? That's 25. So that is correct. Okay. What if I said -7? -7 squared less than or equal to 36. Well, no, 7 squared is 49. But with -7 work over here? Sure, that's true. But it's not true over here because 49 is not 49 is not less than or equal to 36. That is not a true statement. So that's the reason why when we're talking about squares, it's not always the same. All right, multiplying through by a negative number. Okay, this is where you get in trouble as well. This says 5 minus c greater than or equal to 2. Well, what would we do? We subtract 5 here, subtract 5, we have -c is equal to a -3. And then we would multiply. We don't want this to be negative, so we're going to multiply by a -1, right? And that would be c is greater than or equal to 3. Well, is that a true statement? Well, let's plug it in. 5 minus, it's got to be greater than 3, so let's go with 4. 5 minus 4 is 1. Is that greater than 2? That's not true. So what happens when we multiply through by a negative? This is the tricky one. Okay. Whenever you multiply or divide by a negative. Okay. So let's just do this again. Subtract 5. Subtract 5. I got -c greater than -3. Whenever I multiply through by a -1, I have to flip the sign. This just flips. And that becomes a part. So let's see. C's got to be less than 3. Well, what about 2? 5 minus 2. Is that greater than 2? Yeah. So anytime you multiply or divide by a negative, you have to flip your inequality. Okay? Every time. Bonzo's ignoring exponents here. Will they have the same solutions? Oh, wait, sorry. We need to go back up to B. Let's do this other part of B here. When we do B, that's -5 plus C. It's greater than or equal to -2. If I add 5 to both sides, I get C is equal to 3. Is that true? Well, -5 plus 3, is that greater than a -2? Oh, that's the reason why. Because it's not equal. I got to be careful. Oh, this has got to be greater than. So it's got to be greater than 3. So if I plug in a 4, that's going to be a -1. -1, is that greater than a -2? Well, sure it is. -1 is greater than a -2. Okay, so that we didn't multiply through by a negative, so we didn't flip the sign. Only when you multiply or divide by a negative do you flip the sign. Now, Bonzo, C, is ignoring exponents. Do y squared less than 5 squared and y less than 5 have the same solution? Well, if we were to solve this, we would square root and square root. Y would be less than 5. Okay. And that would be plus or minus because it's the square root. Okay. And then if we just did y less than 5, is that true? No, because this could be a this is just y has to be less than 5. This is y's got to be less than a positive 5 and y's going to be less than a negative 5. Okay, what's in between is not going to work. Okay. Let's see here. All right, JoJo was asked to solve 6x plus 12 is less than 3x plus 6 for x. She answered. All right, let's see what she did. She factored out the 6. She factored out the 3. Okay. And so she just said 6 is less than 3. Don't know about that. If I distribute property, multiply through by 1 over that. Okay. Example. So let's see here. Is she correct? Since the final line is a false statement, she deduced that there is no solution to the inequality that makes the solution set empty. Okay, what is the solution set? So let's just solve this. I'm not going to do what she did. I'm not going to factor that out. Why do I want to do that? Let's subtract. Actually, I don't want to do that either. I want to subtract 3 from both sides. 3x minus 3x. That gives me 3x plus 12 less than 6. So if I subtract 12, that's 3x is less than negative 6, divide by 3, divide by 3. Now I'm not dividing by negative, so I'll leave my sign. And there you go. X is less than a negative 2. So let's see what it says. Explain why JoJo came to an erroneous conclusion. Well, because she multiplied by a 1 over x plus 2, and that is just not that smart to do, because we're not sure if that's going to be a positive or a negative. Just don't do stuff like that. All right, solve for negative q greater than or equal to 7. Okay. So let's see here. I've got to multiply through by negative 1. So q, I'm going to flip my sign. Multiply through by negative 1. That becomes a positive 7. Okay. Since I multiply through by a negative 1, I've got to flip my sign, and notice I did that. So this would look like this is 7. Q's got to be less than or equal to it. So that's what we do. Number 11, or question 11, all right. Let's divide by negative 2. Divide by negative 2, we've got to flip our sign. Oh, flip it. Flip the sign because we're dividing by negative. So that would equal 8. Okay. Here, I'm going to multiply through by negative 12. By negative 12. So I'm going to flip my sign. And that would be a negative 3. Let's subtract 6 from both sides here. Negative a greater than or equal to, what was that, 9? But I'm going to multiply through by negative 1 to get my variable to be positive. Oops, I flipped my sign. I'll go back, flip my sign. That's going to be -9. And I'm not graphing these on the number line, but you need to. So this would be a -6x plus, actually it's going to be a -12. It's greater than 0. Add 12 to both sides. -6x is greater than 12. Divide by -6. Divide by -6. Since I have divided by a -6, I got to flip my sign. That's going to be a -2. Okay. Recall the properties. A is greater than B. A plus C is greater than B, then B plus C. Okay. There you go. That's all real. So use the properties of inequalities to show that the following statement is true for any real P and any real Q. So what we would want to do so what it's saying is we want to make this. How do we get this to become this? Well, P greater than or equal to Q. If I multiply by a -1, and that changes my sign, I get -P greater than or equal to, or less than or equal to a -Q. Well, is that what that says? Yes, that is exactly what that says. So that is true. Now, here they multiply through by -5. So if I multiply through by -5, what happens? P multiplied by a -5, -5. That becomes -5P. I got to flip my sign. And Q, and this is -5Q. I don't know why I put that in parentheses, but I did. So are these true? Well, sure, it's true. Oh wait, I got to keep going here because I got to get this to equal. I'm looking for any real numbers of P and Q. So divide through by a -5. I don't know why they would do that. I divide through by -5. I would flip the sign again, and that would be Q. So that's any real number. And we would throw that as equal to or equal to. So that could be any real number. Okay. Based on the inequality FTC, what might be the explanation property of the inequality? I guess I'll go ahead and do this one right quick. Well, look, we multiplied by a negative and we flipped the sign. So we're good. That is a true statement. Okay. That's all you have to look at there. So what we would say here, when A is greater than B, okay, then if you multiply through by KA, that's going to be less than KB. That's if, what are we going to say here? If we have a negative K. Okay, because all we did was flip the sign. We kept A and B in the same spot. Oh, we plus the sign. I guess I need to make these a big K and a big A and a big K. And a big A. Big A and a big B. There. All right, solve this two different ways. First, I'll using without ever multiplying through by a negative number, and then by multiplying through by negative 1/2. Okay, so we start here. I'm just going to combine like terms. That's negative 18 minus 16t. Greater than or equal to negative 6 minus 100t. So let's add 100t. Add 100t. That's going to give me 84t. Negative 18. I add 18 to both sides. That's going to be 12. So if I divide by 84, divide by 84, t is going to be, what will that reduce to? 1/7. Yep. So there's that. Now it wants us to do it by multiplying through by 1/2. Okay. I'm still going to combine like terms. I'm still going to start right here. Okay, so I'm just going to rewrite this as negative 18 minus 16t equal to negative 6 minus 100t. Okay, so instead of that, they're saying go ahead and just add 16t, add 16t. That gives me a negative 84t. I add 6 to both sides. That's going to give me a negative 12. I don't know what multiply. Why do they want to multiply through by negative 1/2? I guess maybe to make these numbers smaller. Seems dumb to me. I would just divide by a negative 84, divide by a negative 84. And when we do that, t, we have to flip the sign. And that would be a positive 1/7. And if you notice, it's the same thing, just written reverse. All right, two different ways. Once again, there's all this again you do is work on flipping your sign whenever you're multiplying through by negative. So we have x over 4 plus 8 greater than 1/2. I'm going to multiply through by I'm going to go ahead and subtract by 8. Subtract by 8. That's negative x over 4 less than a negative 7/2. Multiply through by 4. Multiply through by 4. I get negative x is less than 2830. What did I do there? Is that right? Yeah, that's right. But I have to multiply through by negative 1. And when I multiply by negative, I have to flip my sign. So x has got to be greater than 30. Okay. If I multiply through by negative 4, could have done it without the negatives. Yeah, I would just multiply it by a negative without multiplying through by a negative number. How would you have done it without multiplying through by a negative number? Just do it like that. That's the best way to do it. And that's it.